The next concept is capillary action. That is very important concept. So before we discuss about capillary action, it is very important to know that what is meant by capillary. So initially we have discussed about capillary. Okay, what is meant by capillary? So capillary, capilla, it is a Latin word. In Latin, capilla means hair type, very small. Now capillary is a glass tube, but that type glass tube, this glass tube having very fine bore. Okay, they are having very fine bore. You get it clear? So it is a glass tube, they are having very fine bore. This is called capillary, and such bore is nearly equal to 1 millimeter. Okay, their diameter is nearly equal to 1 millimeter and approximately small for than 1 millimeter. Now capillary is a glass tube having very fine bore. It is simple glass tube. You get it clear? They are having a hole that is fine bore and whose diameter is nearly equal to 1 millimeter. So after that we need to know that what is meant by capillarity. Okay, the next concept according to capillary action. So it is very essential to know that what is meant by capillarity. Let's imagine that this capillary tube is deep into the water. Let's see here. Imagine that this is a container. Okay, so between this container we are taking some amount of liquid, and between this liquid we are just deep and capillary tube. Imagine that this is a capillary tube and this capillary tube is deep into the liquid. So if the liquid weights the capillary, okay, like when the glass capillary tube is deep into the pure water, we know that pure water totally weights the solid. So when the capillary tube is deep into the liquid, that type liquid, the liquid weights the capillary. So then after the level of liquid inside the capillary tube rises above. Okay, the level increases. But if the same capillary tube is deep into the liquid, but liquid does not weight to the capillary tube, so what happens then after? The level of liquid inside the capillary tube falls below. Okay, the level of liquid inside the capillary tube falls below. It means when the glass tube is deep into the pure water, the level of liquid inside the capillary tube rises above, and when the same capillary tube is deep into the mercury does not weights the solid, so it means the level of liquid inside the capillary tube falls below. That is very important. So this condition of level of liquid inside the capillary tube rises above and falls below, so this condition is called capillarity. That is very important. The level of liquid inside the capillary tube rises above and falls below. So this condition is called capillarity. So capillarity indicates the level of liquid inside the capillary tube rises above or falls below. And the condition is very important. When the level of liquid inside the capillary tube rises above, when the capillary tube is deep into the liquid and liquid weights the capillary. Okay. When the level of liquid inside the capillary tube falls below from their original level, now when the capillary is deep into the liquid and liquid does not weight to the capillary, so then after their level will be change, and such change in level inside the capillary tube like rises above and falls below, so this condition is called capillarity. You get it clear? And this capillarity is used as a action. Okay, this word capillarity is used as a action when we are given some examples. When imagine that the oil rises up in the wick of lamp. Okay, oil rises up in the wick of lamp. So automatically oil now step by step the increases through the wick of the lamp. Okay, so this is capillary action. You get it clear? Now then after cloth, rug soaks the water. This is also capillary action. Now sponge soaks the water. This is also capillary action. Now water rises up at the topmost leaves of the tree. This is also capillary action. Blotting paper absorbs the ink. This is also capillary action. Okay, now it means according to the capillary action, the concept of capillarity is very important, because this capillarity, it shows that when the level of liquid inside the capillary tube rises above and when the level of liquid inside the capillary tube falls below. So that's why then after we have discussed why the level of liquid inside the capillary tube rises above and why the level of liquid inside the capillary tube falls below. This condition we are discussed separately. So the next point from this chapter is the capillary rise or fall. Okay, capillary rise or fall, it means the level of liquid increases or decreases. Get it clear? Now according to our government textbook, okay, Maharashtra State Board, now between this textbook, I think capillary fall and their derivations are given, okay, and they shows that the capillary rises as given as compared to this. So that's why now here we are discuss about capillary rise, because capillary fall is totally given from your textbook. That's why we can explain here capillary rise. Okay, the same expression. What is the difference between two? We are discuss after that completion for that point. So let's start it. Why the level of liquid inside the capillary tube rises above? Their condition. Okay, their reason. So let's discuss the next concept, capillary rise. Let's see the next concept, capillary rise. Capillary rise. Okay, capillary rise, it means the level of liquid inside the capillary tube rises above. We can draw the capillary. Imagine that we are given a liquid container, okay. This is a liquid, pure water, imagine that, is given on the beaker and just we take a capillary, just we take the capillary tube, let's imagine this is a capillary tube and this capillary tube is deep into the liquid. Okay. Now when the capillary tube is deep into the liquid and liquid is pure water, so we know that pure water totally and completely weights to the capillary. So that's why the surface is normally concave. Okay, the surface is normally concave. Get it clear? Let's see here. The free surface is normally concave. Okay, the free surface of liquid is normally concave. When the capillary tube, glass capillary tube is deep into the liquid and liquid is pure water. So we know that pure water totally weights the capillary. So that's why the point of contact is concave. Okay. Now let's consider 4 points. We can choose the 4 points. Okay, we can choose the 4 points. Number first, this is point A, this is point B, this is C, and this is D. There are 4 points. Point A, point B, point C, and point D. We are observe the same. The point A present just above the concave surface. Point A present just above the concave surface, but inside the capillary tube. Point B is present just below the concave surface inside the capillary tube. Point C is present just above the free surface of liquid outside the capillary tube, and point D is present just below the free surface of liquid outside the capillary tube. That is very important. Now the pressure at point A is denoted by PA. The pressure at point B is denoted by PB. The pressure at point C is PC, and pressure at point D is denoted by PD. So PA, PB, PC and PD is the total pressure at point A, B, C and D. Now we know that the pressure on the concave side is greater than convex. So concave side pressure is greater and convex side pressure will be minimum. So according to this, we know that the pressure at the point of A is greater than the pressure at the point of B. The pressure on concave side is greater than convex. According to the different shapes of liquid, we are good familiar about this. If the surface is plane, the pressure between two sides is equal and opposite. If the surface is concave or convex, the pressure on the concave side is greater than convex. So that's why the pressure at point A is greater and the pressure at point B will be smaller. So PA is greater than PB. Okay. Now after that, we are observe the same. The point C and point A both present in air. Can both experience the same atmospheric pressure? Yes. Now the pressure at point A and pressure at point C both are same because the reason is atmospheric pressure. Both points are present in air, so they experience the same atmospheric pressure. It means that the value of PA is PC. So PA is greater than PB and PA is equal to PC. Can we write here PC is greater than PB? Yes. The pressure at the point of C is greater than B. Get it clear? Now after that, let's observe the point C and D. Okay, this is the first condition. This is the second condition. The third condition is this. The point C and D. Okay. Just observe the point C and D. Point C and D are just present above and below the free surface. And the free surface of liquid is exactly plane. So it means that there is no pressure difference between 2 points. So we get the pressure at point C is exactly equal to the pressure at point D. Because the reason is point is present just above and below the free surface of liquid and the free surface of liquid is plane. Okay. So PC is equal to PD, but we know that PC is greater than PB. So we can write PC is equal to PD here. So that's why we can represent here. Now PD is greater than PB. Okay, PD is greater than PB. So when PD is greater than PB, okay, when PD is greater than PB, it means that the pressure at point D is higher and inside the capillary tube at the point of B, the pressure will be lower. So we know that very well. The pressure is always moving from higher to lower. So if the outside the capillary tube is pressure will be high and inside the capillary tube the pressure will be low. So that's why the level of liquid inside the capillary tube rises above. Okay, that's why the level of liquid inside the capillary tube is rises above, that type. You get it clear? Why the level of liquid inside the capillary tube rises above? So when the capillary tube is deep into the liquid, now just outside the liquid the pressure will be higher and inside the capillary tube the pressure will be lower. So that's why the pressure will be shifted from higher to lower and finally the level of liquid inside the capillary tube rises above. So this is the reason why the level of liquid inside the capillary tube rises above. That is called capillary rise. You got it clear? But according to textbook, so in the textbook which is given for the expression for capillary fall. So what is the expression for capillary fall? When we discuss about capillary fall, let's see, this is a beaker, this is our capillary tube and this is liquid. When the capillary tube is deep into the mercury, okay, when capillary tube is deep into the mercury does not weights the capillary. So that's why the level of liquid inside the capillary tube falls below. Okay, level of liquid inside the capillary tube falls below. But why? Let's see the reason. Now when the capillary tube is deep into the mercury, so the point of contact is nearly concave. The point of contact is nearly concave. Again we can choose the 4 points, PA, PB, PC and that is PD. Same concept, PD. Okay, same concept will be there. So PA, PB, PC and PD is the pressure at the point of A, B, C and D. So we know that the pressure on the concave side is greater than convex side. So which point is present on the concave side? Let's see. This is the concave side and this is the convex upper. So it means that the pressure at point B is greater than the pressure at point A. So pressure on the concave side is greater than convex. So this is the concave side and this is convex. You get it clear? So pressure inside the liquid will be increases. So pressure at point B is greater than at point A. Again we know that the C and A, they having same atmospheric pressure because they present in air. So we can write here PA is equal to PC. Okay, and C and D are present at same horizontal level from just above and below the free surface of liquid, and the free surface of liquid is plane. It means pressure at point C and D will be same. So pressure at point C, this is equal to pressure at point D. Get it clear? So now between this expression, it is very clear that PB is greater than PA, but PA is equal to PC and PC is equal to PD. So it means that PA is equal to PD. So we can write here the pressure at point B is greater than the pressure at point D. So it means inside the pressure will be maximum and outside pressure will be minimum. So that's why the liquid will be moving from higher pressure to lower pressure, and this is the reason why the level of liquid inside the capillary tube falls below. So this is capillary fall. So capillary rise or capillary fall. Get it clear? Okay. So then after we have discussed the final point from this chapter, the expression for capillary rise or fall. Get it clear? So let's see the last point from surface tension, that is the expression for capillary rise or fall. So can I rub this? Okay, let's discuss the expression for capillary rise or fall. 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 Okay. Let's discuss the expression for capillary rise or fall. We are given liquid. We are given the expression for capillary rise or expression for capillary fall. It means we have find out the expression for height. How amount of level of liquid inside the capillary tube rises above and how amount of level of liquid inside the capillary tube falls below. We are discuss about height. Okay, we are find out the expression for height. It means the expression for capillary rise or fall. Let's imagine that this is a capillary tube and this capillary tube is deep into the liquid. You get it clear? And what happened there? Let's we are consider the level of liquid inside the capillary tube rises above. The level of liquid inside the capillary tube rises above. So capillary is the glass tube. It is a circular. Okay, it is a circular tube, that type. And when the liquid rises above inside the glass tube, so definitely the circular shape of liquid is moving vertically upward. So actually the length of contact in liquid inside the capillary tube is circular. So this is a liquid meniscus. Okay, this liquid meniscus is circular and their length of contact is 2 pi r. 2 pi r is the length of contact with the solid. Solid and liquid both are contacting together, and the circular liquid in the circular shape of liquid is moving vertically upward. It means their point of contact is circular. The length of contact with the solid in a liquid, that is 2 pi r. This is very important. Now after that we are discuss about the expression for capillary rise or fall. and this expression we have find out between two ways. Okay, there are two different methods, and by using these two methods we have find out the expression for capillary rise or fall. So initially we have discussed the first method, method 1, by pressure difference, method. Okay, by pressure difference method we are discuss about the expression for capillary rise. Now this is a liquid meniscus and which is circular, you get it clear. So whose radius will be denoted by capital R. So capital R is the radius of the liquid meniscus, and radius of the capillary tube will be denoted by small r. This is a point of contact. So we can draw the tangent here. When we draw the tangent, so they are making an angle, that is angle of contact theta. Now exactly similar theta will be here between the triangle. We are given the name of this. Now imagine that this is A, this is B, and this is C. Okay. Now according to the weight of the liquid column, so this weight of the liquid column is present due to their pressure difference, and the pressure difference due to the water, we know that the pressure difference due to the water, that is Pi minus Po, that is excess of pressure, this is denoted by 2T upon R. You got it clear? And according to the concept of pressure, we know that the excess pressure will be denoted by H rho G. This is the excess pressure. So what is by rho? Rho is the density of the liquid, density of the water, and G is the acceleration due to gravity, and H is the height. So this excess of pressure H rho G is equal to 2T upon R. Get it clear? But according to this diagram, in triangle, now in which triangle ABC, so what is the value of cos theta? So cos theta is equal to, now adjacent side upon hypotenuse, it means small r divided by capital R, adjacent side upon hypotenuse, horizontal upon hypotenuse. And by using this, now we find out the value of capital R. So capital R is equal to small r divided by cos theta. So put this value from this equation, what we get? Otherwise call equation number 1 and this is equation number 2. Put the value of R in equation number 1. So we get H rho G. Okay, therefore we get H rho G is equal to 2T divided by R. R is equal to what? Small r divided by cos theta. So cos theta, take a numerator. So what we get? Now we get H rho G, this is equal to 2T cos theta upon what is remaining? Small r. 2T cos theta upon r. And if we find out H, so H is equal to, what is H? H is equal to 2T cos theta divided by which factors are remaining? R rho G. So this is the expression for capillary rise. Okay, this is the expression for capillary rise. So if the capillary tube is deep into the liquid and level of liquid inside the capillary tube rises above or falls below. So how amount of level of liquid inside the capillary tube rises above and falls below? This amount, it means height. The expression of height is here. H is equal to 2T cos theta upon R rho G. So by using this expression, we are easily calculated the how amount of level of liquid inside the capillary tube rises above and falls below by using pressure difference method. Get it clear? The same expression we have find out by using method force. Okay, by using the method force. Let's discuss the last expression, the expression for capillary rise by using the method force. Okay, this is the method of pressure difference. So let's find out the same expression by using pressure difference method. We can show here, but then before we can rub this. Okay, the same diagram we can use. The next, by method force, by using force method. We are trying to find out the same expression. Let's imagine that this is capillary tube and this capillary tube is deep into the liquid. This is liquid. Okay, this is liquid, and we consider the level of liquid inside the capillary tube rises above and the point of contact is concave, that type. Okay, the point of contact will be concave. The total height of the liquid, which is denoted by h, from the surface of liquid. Now we can draw the tangent. We are trying to draw the tangent at the point of contact. Such tangent is making an angle inside the liquid, that is angle of contact. Now this tangent is also drawing here. Okay, this is also here and this is also theta. Get it clear? Now after that, we know that the level of liquid inside the capillary tube rises above. So this is the force due to surface tension, that is Ft. Okay, this is the force due to surface tension, Ft. And this force due to surface tension is exactly equal to the tangent, which makes an angle of contact. Now this force due to surface tension, Ft, is these all mainly two mutual perpendicular components. There are two mutual perpendicular components. Now this is horizontal component, and we can draw here the vertical component. Exactly similar here. This is vertical and horizontal components. Tell me, this Ft is the force due to surface tension. You get it clear? And their vertical component will be denoted by, this is the vertical component. Actually this is the glass and this force will be vertical. This is glass, this is horizontal. You get it clear? So that's why we can write here Ft sin theta. Okay, we can write here Ft sin theta, force due to surface tension. This is also Ft sin theta. Now but here this is Ft cos theta and this is also Ft cos theta. This is the tangent. Okay, this is force due to surface tension, tangent. Okay, now when the level of liquid inside the capillary tube rises above, the point of contact, okay, the length of contact in solid, this is denoted by 2 pi r. The length of contact of liquid inside the capillary tube is 2 pi r, because in circular shape the level of liquid inside the capillary tube rises above. You get it clear? Because capillary tube is the circular and they are having very fine bore. When the level increases for the liquid, now their shape is definitely circular. So point of contact is definitely, the length of contact is 2 pi r. Get it clear? This is the liquid meniscus and which is having circumference of circle. Get it clear? Now after that, now initially we had discussed the same, which amount of force due to surface tension experienced by the liquid meniscus. So this force due to surface tension Ft is equal to, as per the definition of surface tension. So what is the definition of surface tension? So surface tension T is equal to force per unit length. So which force is experienced? So force is equal to surface tension into length. So it means that the force due to surface tension, that is force, is equal to surface tension into length in contact. Okay, length in contact. So this force due to surface tension is equal to, surface tension will be denoted by T and length in contact will be denoted by 2 pi r. The total length of the liquid is contact with solid is having circumference of circle. It means the length of contact is 2 pi r. So this is the force due to surface tension. That is very important. Call equation number 1. Get it clear? Now after that, the level of liquid inside the capillary tube moving vertically upward. So that's why the vertical component Ft sin theta from two sides are equal and opposite, because level moving vertically upward. So these vertical components are cancelled together. We are only given the horizontal component of force due to surface tension, that is vertically upward. You get it clear? So this vertical component of the force, now we can write here the vertical component of the force due to surface tension. So this is equal to vertical component Ft cos theta. Okay, Ft cos theta, but value of Ft we are already calculated. So it means we find out the force due to surface tension due to vertical component is equal to Ft. Ft means what? 2 into 2 pi r, or this is cos theta into cos theta. Call equation number second. This is total vertical upward force. Okay, this is equation number second, and this equation number second indicates that the total vertical upward force due to the force due to surface tension, okay, which is represents the total vertical upward force. This is the expression for the total vertical upward force. Get it clear? Now after that, when the level of liquid inside the capillary tube rises above and reaches at a particular height, okay, the total weight of the liquid meniscus will be balanced. The total weight of the liquid meniscus will be balanced, and the direction of the weight is vertically downward. The total weight of the liquid column is vertically downward. So here weight, that is mg, g for acceleration due to gravity. It means when the level of liquid inside the capillary tube rises above, now definitely their liquid column, this liquid meniscus, experience the gravitational force in downward direction due to their weight. So it means they experience the downward force. Their vertically upward force will be denoted by Ft is equal to T into 2 pi r into cos theta. So what amount of downward force experienced by the liquid meniscus? So we can find out the total vertical downward force. Okay, so the vertical downward force we find out due to their weight of the liquid column, and weight will be denoted by mg. Weight of the liquid column will be denoted by mg. So m is the mass of the liquid column. Okay, m is the mass of the liquid column, and this mass we can find out by using density. So we know that density is equal to mass per unit volume. So definitely we find out mass is equal to volume into density. Get it clear? So what is the volume? It is a circular of shape. So it means that the mass m is equal to volume what? Area 4 pi square into height. Okay, pi r square into h. This is the volume. Pi r square is the area of the circle and height total. Okay, so it means that we find out the total volume of the liquid column just inside the capillary tube, and into density becomes same. So this is the value of mass. So put this value from this equation. So we get the weight. So weight is equal to m. M is pi r square h rho, and this is the g. So this is the total weight of the liquid column. The weight of the liquid column will be here. W is equal to pi r square h rho g, and this weight indicates that the total vertical downward force. This is the expression for total vertical upward force, and this is the total vertical downward force. Now when the level of liquid inside the capillary tube rises above and it will be stable, it means that the total vertical and downward both forces will be same, that is equal and opposite. So comparing equation 3 and 2. Okay, due to this comparing equation 2 and 3. So when we comparing equation 2 and 3, so equation number 2 is T into 2 pi r cos theta. This is equal to pi r square h rho g. So let's find out h. So therefore h is equal to what? T into 2 pi r cos theta whole divided by what is remaining? Pi. Now here r square and rho g. So which factors will be cancelled? Let's see. Pi get cancelled. Now 1 r will be cancelled. So what is remaining? Remaining h is equal to 2t cos theta upon 1 r will be remaining, and rho g, r rho g. The same expression for height we are calculated by using force, by using the method force. Now when the capillary tube is deep into the liquid and level of liquid inside the capillary tube rises above. You get it clear? Now after that they experience vertical upward force, and due to the weight of the liquid column they experience the vertical downward force. And according to the stability, according to the equilibrium position of the liquid column, now vertical upward and downward force both are same. So that's why we are comparing these two equations, and finally we find out the same expression for height. Okay, and by using this equation we also find out the value of T. We also find out the value of surface tension. So T is equal to, so what we find out, T is equal to HR rho g, HR rho g divided by, what is divided by? T cos theta, divided by T cos theta. So by using the expression for rise, expression for height, we also find out the expression for surface tension, T for surface tension and H for height. Get it clear? Now here the total concepts related to the surface tension will be over. Now between this concept surface tension, initially we have discussed, just we are remind all that concepts. Initially we have discussed the molecular theory, and according to molecular theory we have discussed the intermolecular force. There are two types, cohesive force and adhesive force. Then after we have discussed about range of molecular force. Then after the definition of sphere of influence. After that surface film, and finally we have discussed the free surface of liquid. And by using this we have discussed the definition of surface energy and surface tension. So after that we have discussed the relationship between surface energy and surface tension, and this relationship we get T is equal to dW upon dA. That is very important equation. Now finally after that we have discussed the concept of angle of contact, and there are different cases about acute angle of contact, about obtuse angle of contact, about zero angle of contact and 90-degree angle of contact. So after that we have discussed which factors affecting on the concept of angle of contact. So we are three factors we have discussed: the effect of impurity, effect of temperature and the nature of liquid and solid in contact. You get it clear? After that we have discussed the effect of impurities, then after we have discussed the effect of temperature, and finally we have discussed the excess of pressure due to the shape of liquid column. Okay, if the free surface of liquid is plane, the force due to surface tension between two sides is equal and opposite. When the free surface of liquid is concave or convex, the pressure on the concave side is greater than convex side. That is very important. And after that we have discussed the capillary, capillarity and capillary action. And according to this we have discussed the expression for capillary rise or fall. But then before we have discussed why the level of liquid inside the capillary tube rises above and falls below. These conditions we have discussed, and after that condition now we have discussed the expression for capillary rise by using pressure difference method and by using force method. And finally the total concepts related to the surface tension will be over. Okay, so we can stop here.